Okay, just a few examples to get you rolling. So on this one, it says find the scale factor. And so the scale factor, remember, is what you multiply by to get the new ones. And that's why I like it, because students get confused with the ratio about old versus new, but somehow they feel a little better about saying that the old times the scale factor is going to give me the new. And if these two are similar, and they say that they are, then we could put in any corresponding sides. So I'll just do AC since it's on the left. Whoops. Forget that. It's 4.5 times the scale factor, which is K. So 4.5 times K equals the resulting side, and AB. Oh, this is true. I'm sorry. AC is what I went for. AC corresponds to ln. So yes, it corresponds to this side. It's equal to 6. So the scale factor is 6 divided by 4.5, which is the equivalent of 4/3, or about 1.3 repeating, or equal to 1.3 repeating. So that's the scale factor. Cool. Now, I'm not going to go through all this problem. Then list all pairs of congruent angles and write the ratios of the corresponding side lengths in the statement of proportionality. That'll just get kind of tedious to know that angle A equals angle L, and angle C equals angle N, and angle B equals angle M. You could get all that from the congruency, the similarity statement. But I do want to say about the ratios of the corresponding side lengths in a statement of proportionality. A statement of proportionality is what we normally just call proportion, which is just two ratios that are equal to each other. So, for example, you could say that that ln over AC, so 6 over 4.5, is going to be equal to 9 over 6.75. Because these all are going to be equal to the scale factor, which is there's one scale factor for each one. And you could also say that's equal to 8 over 6. Right. Next one. Oh. The polygons are similar. Find the value. Got pretty good sleep last night, too. Find the value of x. So they say they're similar, but I got to make sure I'm matching it up in the right way. It's pretty obvious on this one, but this is the kind of thing you have to watch out for. So x is the one between 3 and 2, so that corresponds to the 20 on this one. And so I could say 20 is to x as, and then I just need to get two other corresponding ones. So I'll get 21, that's between the 3 and the 1, is to 14. So 20 is to x as, well, I'm sorry. Ooh, got that a little bit wrong, didn't I? Yes, I did. Whoa, good thing I checked. So 20 is to x as, I've got to go the same way. I've got to go the new one to the old one. 14 is to 21. So I didn't make sure that I was going the same way both times. You know, I said 20 is to x, so that means I have to go from the right-hand triangle to the left-hand triangle both times. That was a total, just a whoops for a moment, and good thing I fixed it. So now we've got to solve this proportion. We'll do that in a moment, but I'm going to do 20 over x. I'm first going to make it a little easier by reducing this fraction. That would be 2/3 if you divide each by 7. And so how do you solve a proportion like this? So there's two ways that are really equivalent, but we'll show them both to you. One is called cross-multiplying, where you multiply the things across the diagonal. I'm going to erase it in a second, but you multiply this way, and you multiply this way, and you set them equal to each other. You've probably seen that before, and there's nothing wrong with that, and I often do that myself. But just for the record, the way it works is that we're going to get rid of the fractions, so we multiply both sides by 3 over 1. And that will cancel out the 3 on this side. And then, there's an x down here. So let's multiply by x over 1 too. And x over 1. And so the x's cancel out over here. So I end up getting 3 times 20 equals 2 times x. And if you check this out, this is exactly what we get if we cross-multiplied a while ago. 20 times 3 equals x times 2. There it is. So cross-multiplying is just a fast way to say I multiply both sides by the denominators to clear out the fractions. Okay, equals. So 2x is 60, so x equals 30. And then I can put the 30 in for x, and I can just kind of check the ratios. 30 is to 20, as 21 is to 14. Yeah, that looks good. Next one says RSTU is similar to ABCD. Find the ratio of their perimeters. So they want the new perimeter to the old perimeter. This is one place where that scale factor idea in the fraction version, that kind of makes sense here. So all I need to do to know the ratio of the new perimeter to the old perimeter is I just need to know what the scale factor is. And that's why they gave me the numbers in here. Now, which one does 12 go to? Looks like 8, but I'm just going to make sure. So ST goes with BC, so 12 goes with 8. So the scale factor is new over old, so that's 2/3. And that kind of makes sense from the picture. Looks like 2/3 is big. So that means the ratio of the perimeters, I don't know why I got a lot of sleep, is the new one over the old one, which would be 2/3, because that's the scale factor. Remember, that's what we said earlier. I just worked out what the scale factor was. So that's the ratio of the new perimeter to the old perimeter. It's a ratio of the new side length to the old side length, which is the same as the ratio of the new perimeter to the old perimeter. Now this one's going to be a little bit different, so let's see how this is going to be different here. Let's work out the scale factor first. So the scale factor is that the new value of this side is equal to the scale factor times the old value of that side. 3 times something gives me 6 as an answer, so the scale factor is just 2. Now I'm going to do this one my way, the way I like to do them, but it's totally up to you. You can do it with ratios too. So what I say is that the new perimeter, area, is equal to K times the old area. No, it's not. So I made that mistake intentionally. That one I did intentionally. It's K squared times the old area. Remember that from earlier, that the new area is the old area times the scale factor squared, not just times the scale factor. So the old area is 27, but I've got a scale factor of 1. I've got a scale factor of 2, and so that means the new area is going to be 4 times as big. So the new area is 108 feet squared. Square feet. That was the last one, right? Yeah. And just really quickly, you could have done this a different way. Just take a little bit. You could say, all right, well, if the area is 27, then I know this one is 3 by 9, because that's the only way you multiply them to make 27. It's a rectangle. And so now everything is twice as big, so this would be 18. So the area is 6 times 18, and you know what that is? That's 108 feet squared. So you see how you could work it out by hand this way, but you actually could work it out over here by just going with a scale factor. I know when the sides get twice as big, then the area will get 4 times as big, and that gave me the answer. Okay? So what did we learn today with these videos? We learned what similar figures are, bigger or smaller versions of the same, of an original figure. And the scale factor is what you multiply by to get the new one. So if you've gotten bigger, you're going to multiply by something bigger than 1. If you get smaller, then you're multiplying by something less than 1. We learned how to write a similarity statement, and it's like, okay, it's like a congruent statement, but it's a similarity statement. But keep in mind, what that means is not that the sides are equal. It means the ratio of the sides will be equal. So AB will be to A prime, B prime, as BC is to B prime, C prime. That all, and AC and A prime, C prime. We learned that angles stay the same in similar figures, but sides get affected by the scale factor. And so the new perimeter will just be the scale factor times the old perimeter. But the weird one, it's just not immediately obvious. It's not like the first thing you'd think. The new area is the old area times the scale factor squared, not the original scale factor. And we saw an example where it was like really obvious that, if you make this thing 3 times bigger on each side, then the area is actually 9 times bigger, not 3 times bigger when that's a scale factor. And then we just looked at a few examples. Tonight's homework is going to be mostly the videos and then just a couple of examples. So that'll kind of get you ready for tomorrow, and then we'll kind of clean up on similar figures tomorrow. Okay, we'll see you Thursday.